Hey, what's up YouTube? If you're taking the construction civil exam, the economics part can be confusing, but lucky for you guys, I'm here to teach you. So let's get right into it. Financial analysis thoughts on what these discount rates all mean. P/F, P/A, P/G, F/P, F, A/P, A/G. What does that all mean even? So basically in the financial analysis, what you want to remember is the time value of money. And basically what that means is you have cash, but when do you spend it? And is it making you money or is it losing you money? That's the whole idea of this analysis. And this provides great economic tools to make comparisons, whether you should invest in this or you should pay less for this option. That's basically what it comes down to. And so the book over here, we're using the Civil Engineering Reference Manual, page 8729, and Appendix A-179. And in this appendix, it gives you all the discount rates. And so you don't have to actually calculate it because they're logarithmic functions, and you don't really want to spend the time on the test doing that. You really just want to look them up in this appendix. So taking a look at these symbols, P/F, and basically how I like to view it is present value as a derivative of future value. So you'll see the first one as the one you're converting to basically. And so this P/F basically gives me the present value, whereas F/P, that would give me the future value. So what that means is, in this case for P/F, we can find the discounted future values. And that means that if you're going to make an investment, it's going to be discounted at a certain rate. Now in the real world, if I were to invest in, say, a stock or something, I would discount it at whatever the treasury rate is. The treasury is controlling the amount of inflation. So let's move on. P/A, basically for an annuity, you can find the present value. Say if you're making payments on a phone bill, then you can find the present value in the middle of all those payments. Present value for gradient, that basically means similar to that one. The gradient is growing in each unit of time. You're paying more and more. F/P, compound future value. That just means what do you expect your present value to multiply at? Is it at 8%? And then you choose a time t equals n. And this is important because for these past three, and I drew the line here, these are all present values. So if they ask you on a test, what is the present value of this or that, you're basically going to be using one of these three factors. If it's going to ask you to compare something at a future time, then you have a majority of these other ones. And so now I'm going to go down the way and figure out what the differences between each are. This one, like I said, is kind of like stocks. Apple today is at 167. If you anticipate an 8% year-over-year return, then you would probably use this for however many years in the future you want to project. A/P, given the present value, what is the value of the annuity at t equals n? And this one is basically kind of saying at t equals n, what is the value of this annuity given, you're given a present value. And so an annuity is basically just a structured uniform series, like structured payments, or you're getting like rent or something every month, so it's consistent. A/G is just like A/P, except the gradient is going higher at each interval, each unit of time. So t equals 1 will be this high, and then t equals 2 it gets a little bit higher. whereas this one just stays flat. F/A, that just means the annuity, kind of like this, and you're given an annuity and now you're going to get the future value of that annuity at some later time. So it's kind of like a future to future kind of analysis. A/F, you're given the future value and you want to convert that into a uniform series, also known as an annuity. And so one of my favorite problems right here that kind of ties it all together is this return on interest problems. And as you can see, to make things easier, because I know on the test when you get things and you look at it and you're like, oh my gosh, interest, oh my gosh, t equals n, oh my gosh, how much is it worth? You kind of get confused, so you just want to stop, draw this arrow diagram if it helps you, and it's pretty helpful. And so one of the typical ones, return on investment, they'll give you an initial cost at t equals 0. So any kind of initial costs, they always go on t equals 0. So you put it on t equals 0, and then you set it up. If it's an annuity, like, oh, it's an apartment and they're paying me rent, that's up positive, and so we got an annuity, up, up, up. Then we plan to sell the apartment at some future date, so we have a salvage value, bam, and then you get one big spike up. And that's the typical return on investment problem. And then so, depending on what they ask, they could be asking, what is the present value of this investment? If they ask you the present value, then you're going to basically want to do, you're going to have to convert this annuity into the present, so that would be P/A, and then also this salvage value, P/F, you got to take it to the present side, and that's over, and that's here. So you just add those two up, and then subtract the initial cost, and that would give you what would be on the P side. Okay, so I added two things. So here for the present value, if we take a look at it, we have the initial cost right here, and then we're gonna add the present value of this annuity, and then you're also gonna add the present value of this future salvage cost. And why we want to do P/A, P/F is basically because anytime you move along this graph, you're going to need to do a function P/A, P/F, because you need to discount the rate for each unit that it's moving. And you don't want to figure out that interest rate on your calculator. It's going to take too long. So you need to understand this nomenclature if you're going to use the tables on the test. One thing to remember is that all of these are always a product, and basically it is the price times the interest rate, and then so that's for this one, that always has an interest rate. Then these are also for whatever t equals n, right? There's also, because it's moving along here, t equals n, moving along here, t equals n, and then they also have a price times an interest rate. And then so over here, on this side, future value, have the same kind of thing. And for the initial cost, we need to do the future value, the compound future value. And so basically, since this initial cost is going to be moving along there, we need to normalize it for the interest rate. And then also F/A, this annuity, what is the future value of that? Salvage value, we'll just treat it the price times whatever interest rate is, and you don't need to put any more units other than that because it's already at the current time. So whatever the current interest rate is, and you can use that. Yeah, that's it for today. See you guys soon.